All right, welcome class to part 3 of stoichiometry. Today we're going to be dealing with mass-to-mass conversions, and it would be handy if you had your periodic table with you and your calculator with you so that you could kind of do these calculations and you can kind of follow along what I'm doing as we go along here. We've already gone over how to go from mole to mole conversions in stoichiometry and mass to mole or mole to mass conversions. And now we're going to take that one additional step, and that is mass to mass conversions. And again, we compared this, before we start here, we compared this, our chemical equation is kind of like our recipe for a chemical reaction. And what stoichiometry to some extent is used for is if we would want to change that recipe in the sense of if I'm making chocolate chip cookies and I want to double my recipe or quadruple my recipe, and I know, okay, that means I have to use, twice as much or 4 times as much flour. How does that change all my other ingredients? In the same way, the same thing is true with a chemical reaction. If I change one of my elements and I have more or less than I normally would in my recipe, how would that affect everything else? And that's basically what we're doing. And today we're kind of going to go from the practical side, grams of one thing. So if I have X amount of grams of this, how many grams am I going to end up with? So let's take a look at that, and let's move to our next slide here. And you notice at the top it says mass-to-mass conversions, and we have our equation, the same equation that's in your notes, same equation that we've been using for the last couple presentations here. And the question is, if I have 50 grams of phosphorus, how many grams of diphosphorus pentoxide will be produced? So if I was to get my laser pointer out here just for a second before we solve this, here's my equation, and I have phosphorus right here, and that's my starting point. I have 50 grams of that. That's what it tells me right here, and it's asking how many grams of diphosphorus pentoxide. So that's this right over here. So I want to go from this substance into this substance. And a reminder that the only way we can do that is by using moles. Remember, we can go from moles of one thing to moles of another. Currently, I'm not in moles. So my very first step is to go from grams of phosphorus to moles of phosphorus. And so you'll notice that I have that set up here. And again, you always start by writing what you know, which is 50 grams of phosphorus. So I wrote that down. And then anytime I'm converting, even if I don't remember what I'm converting into, I'm always going to multiply by a fraction. And you're always going to put on your bottom here what you want to get out of. Okay, so I'm in grams. I don't want to be in grams. So I put that on bottom so these two cancel out. And again, I'm always doing units first before I deal with numbers. And then I want to go to moles of phosphorus. Remember, I can't go from grams of phosphorus to moles of diphosphorus pentoxide. There's no connection between the two, no direct relationship. So I first have to go to moles of phosphorus. And then I'm going to look at what's the relationship between moles and grams here. Well, moles is always 1. In 1 mole, how many grams are there? I'm going to go to my periodic table to find that out. And I have 4 phosphorus. And if I look on my chart, phosphorus is 30.97. And so I end up that my molar mass is 123.88. Ooh, that's a horrible 8 there, but we'll live with it. And then I'm going to go ahead and do my math, and I should end up with, let's see here, 50 divided by 123.88. My answer should end up being 0.4 moles of phosphorus, which you'll see as we move on to this next step. That's what I've got there. So now I have moles of phosphorus. So I've made my first step, and now I'm going to move on. Obviously, the question is, if we back up for a second here, if you look at the question again, or you can look at it in your notes, I had 50 grams of phosphorus. I want to know grams of diphosphorus pentoxide. So I converted from grams of phosphorus to moles of phosphorus, but I'm still in the wrong substance. I want to be in diphosphorus pentoxide. But we're okay now because we're in moles. So I can go from moles of one substance or compound 2 moles of another compound. And so that's what I'm going to do. I'm setting up my ratio here between the two. And so I put moles of the substance that I'm currently in on the bottom so that it cancels out here. And then I put the moles of the substance I want to be in up top in my fraction. And then the values, if you remember, the values that I put here are the coefficients. Whenever you're going from moles to moles, those are the coefficients in the chemical equation, which in this case, the coefficient for diphosphorus pentoxide is 2, and the coefficient for P4 is 1. So I'm going to multiply my answer on my calculator there by 2, and you notice it gives me 0.81. And again, remember, you want to, on the reason why we went from 0.4 there to 0.81 is because on your calculator you're actually going to use the full complete number. You're not going to round off until the very end, the final answer. Here on the board or on your paper you can round off just to save space, but you actually want to use the full number. So that's just a quick reminder. All right, so I have 0.81 moles of diphosphorus pentoxide. So now I'm in the right substance, but I'm not in the right units, so I have to convert from moles to grams. So this is my third step. So notice that this problem, whenever you go from mass or grams of one thing to grams of another, then there's going to be 3 steps involved. So just bear that in mind. And so I'm going to convert from moles to grams. Notice I put moles on bottom, so moles cancels out. Always deal with and worry about your units first. And I want to get into grams, so I'm putting grams up top. And whenever I'm going from grams into moles or moles into grams, moles is 1. And in 1 mole, how many grams are there? I'm going to go to my periodic table, and I'm going to add it up there. And I have diphosphorus pentoxide, and I have 2 phosphorus, which is 30.97, and that ends up being 61.94, and add that to 5 oxygens, which I think is 80, and you should end up with an answer. My molar mass is 141.94. And we'll multiply that by 0.81, and we should get an answer that's equal to 114.97. Okay, approximately. And again, the units that I would use for this is grams, and specifically this is grams of diphosphorus pentoxide. Is my answer there. So it's a 3-step process. It's a little bit longer, but that's what we're looking for there on that one. So let's try one more, and I'd like you, if at all possible, to get kind of a jump start. I'll wait for just a second, kind of give you a head start. If you can try the first step on your own on the next problem there in your notes, and get a jump start on me before I kind of begin it here. Same equation. We have a new question in this one. If you want to produce 2,500 grams of diphosphorus pentoxide, how many grams of oxygen would you need? And so here we go. We have this set up. Hopefully you wrote something similar to this in your, if you did your work, or if you're setting it up right now, that would be kind of something how you would set it up. You have your 2,500 grams of diphosphorus pentoxide, and that's your starting point. So let me start with my laser pointer here. Here's my starting point. It's given to me in the problem, so I'm going to write that down over here, and then I'm going to set up my grams on bottom here, so my grams cancel out, and I put moles because I want to convert from grams to moles. And the reason I want to do that, remember, my ultimate goal is to go from diphosphorus pentoxide to grams of oxygen. So the only way to jump from one substance to the other is by going from moles to moles, and I'm not currently in moles, so that's my very first thing that I need to do. And so let's go ahead and take care of that. And so we set this up. grams are going to cancel out. So far, so good. Moles is always 1. In 1 mole, how many grams do I have? And this was, I think, 141.94. And so we write that in, and then if we did our math there, we'd end up finding out that this ends up equaling 17.61. Let me, 2,500. And so we have 17.61, and again, remember to leave the full number on your calculator there. And that's moles of diphosphorus pentoxide. Remember, we don't want to be in moles of diphosphorus pentoxide. We want to be in moles of oxygen. So I'm going to set up a new fraction to cancel out moles of diphosphorus pentoxide. And I want to be in moles of oxygen. And then, because I'm going from moles to moles, I'm going to use my ratio between them. And so I'm going to use my coefficients that are there in the equation. And so 2, that would be 5, and diphosphorus pentoxide, that would be 2. So those are my coefficients there. Then I'm going to go ahead and do my math, and I should end up with 44.03 moles of oxygen. And now that I have moles of oxygen, I have the right substance. Now I need to do is convert from moles to grams. So I put moles on the bottom. Moles are going to cancel out, and moles is always 1. In 1 mole, how many grams are there? I'm going to go to the periodic table, and this should be 32, because remember, each oxygen is 16, and we have 2 of them. So then I go ahead and I do my math from there, and I should end up with an answer that's equal to 1,409.05 basically. And again, this is grams. So I want to put my units in there. Never forget to put your units, and specifically grams of O2, and I am done. And so that's how you do a mass-to-mass conversion. It's just that one additional step. And again, the key to all of this, and I know you've heard me say this a lot of times, but let your units guide you. Don't put numbers in until you've taken care of your units first. If you don't do that, then inevitably you're going to end up putting wrong values in the wrong spot and end up with an incorrect answer. So let your units guide you. That will be a great help to you. All right, we're done.